Okay, so we've been looking at transformations of functions and looking at parent functions, what we were calling them. You had a library of functions that you should know the general shape of, and then doing transformations on those functions. And so yesterday we kind of stopped at this example where if you had this point, -3, 5 is on our function g of x. So this must be g of x right here. Then what is the point on, let me pull that up. What is the point on y equals f of x plus 1? Actually, this wasn't g of x. Maybe I was doing a different problem. Oh, this was g. Okay, now we have the problem. Okay, so we want to look at what's going on with a function. What are we doing to y? What transformations are we doing? And remember, order mattered. We wanted to do horizontal transformations, and then we wanted to do any reflections. Then we wanted to do any shrinking or stretching, and then any vertical transformations. When we were graphing, here, this +1, inside the parentheses, this is what is causing a horizontal shift. And it's the opposite number inside the parentheses of what it's doing. And so this is shifting our graph to the left 1. And then this -3, this is doing a vertical shift outside. And the -3, this is shifting you down 3. Okay, well, shifting things to left, that's affecting our x value. And so if we're going to the left 3, and our point was at -3, I'm sorry, we're going to the left 1, and our point was at -3, then our new x value is going to be -3 minus 1. So it is now at -4. And then our y value, since we're shifting it down 3, so from 5, our y value down 3, so 5 minus 3 is 2. And so our new point, if we know -3, 5 was a point, our new point, -4, 2 would be the point on that graph. So let's look at it. What if it was -3? So what is the point on y equals -3 g of x minus 4 and then +3. Okay, so we're still looking at this point, -3, 5, and we're seeing what transformations we're doing to get our new point on this. And so again, let's kind of go through what's happening to our function. That -4, x minus 4, that -4, this shifts my graph to the opposite minus, so it's going to be to the right 4. So because it's going to the right, I know that's affecting my x value because it's horizontal for x. This is going to be adding a 4 to X value. We have this -3 outside, and that -3, think of it, this is g of x. And so basically you're multiplying this g of x is another way to say y, by -3. And so this -3 is actually, the negative is doing a reflection, but the 3 is also stretching or shrinking. And so this is -3 times y. And this +3 is also affecting the y value. That +3, it's shifting it up 3 value, up 3. So we're shifting it up, we're adding 3 to our y value. So looking at that from our point, the transformation, so we have, what are we doing to x? The only thing that we're doing to our x value is adding the 4. So our x value here for our point is -3, but then we're going to add 4 to that, so +4. And now looking at what we're doing with our y value. So this is where order matters in the order that you're going to do things. And stretching and reflection comes before vertical. And so we're first going to multiply the y value by -3. So -3 times our y value, but our y value in our point was 5. And then shifting it up, we had to add 3 to that point, or y value. Okay, so let's just simplify. So -3 plus 4, our new x value of our point with that transformation from -3, 5 is now 1. And our y value, -3 times 5 is -15 plus 3. -15 plus 3 is -12. So our new y value of that point that shifted is -12. There's a couple that I wanted. I was trying to find that problem earlier today and I was like, oh, this is a really great problem. Okay, here we go. So the direction says we're going to find the function that is finally graphed after each of the following transformation is applied to y equals the square root of x. Okay, so we have y is equal to the square root of x. If you did the following transformations, to y, what would be the equation? Okay, following transformation, let me just list it. So we are going to shift up to, reflected across the x-axis, and reflect it about the y-axis. I'm just wondering if this 1, 2, 3 is the order they want us to do things, because if that is the case, it's going to affect things. If we did it the order that we're supposed to do things in the when we were doing transformations of functions, then we should do this in a different order. Reflection comes before shifting up or down. And so let me just do that first. So let's look at reflection across the x-axis, and it doesn't matter which one you do first. And so if we look at the reflection across the x-axis, well, think about it. Let's look at the xy axis. If you have a reflection, so if I have a point here, and that's a reflection across the x-axis, basically your x value is staying the same, but your y value is changing. So when it's reflected across the x-axis, you're going to multiply y by -1. When you're thinking about it being across the y-axis, well, that affects the x value of your point. So if I have a point here and it's reflected across the y-axis, my y value, is the same, but my x value is not. And so my x value is just changed signs. And so here we're going to change our x. So multiply x by -1. So doing that so far, let's put that in there. So multiplying y by -1, we have this y is equal to the square root of x. And so we have -1 times y is equal to the square root, and we're multiplying -1 by our x value. Wrong colors. And then last but not least is the adding to, shifted up to. You're adding to outside the original. So +2 outside of the radical. Okay, I'm not quite done because I need to solve for y. So we want to rewrite this as y equals. So I'm almost there. All I need to do is multiply every single term by -1, and I could do that because it's an equation. And if I do that, multiplying by both sides by -1, that would give me positive y is equal to, we'll have to distribute that negative, so negative square root of -x minus 2.
So for this equation, do we also have to clarify that x has to be less than 1?
Yes. Well, no, you don't have to. That's just the transformations. But if it asks for the domain of that, you're right. It would have to be less than or equal to, it's actually at less than or equal to 0. right? Any number that is negative would make a positive underneath that radical, and it would be defined. That doesn't have the answer. Okay, so that is the last bit that we're doing in chapter 3. And we're only covering we're only covering 3 sections in chapter 4. And one is on linear equations and average rate of change. So it's kind of review what we already covered back in chapter 2. Also, it's graphing quadratic equations. So a little more review and using transformations, and then looking at nonlinear inequalities. So let me get a new page. Okay, let me just go through this. So this is properties of linear functions. So if we have a function in the form of f of x equals mx plus b, this is, right, a linear line or a linear function. We know that m is equal to our slope, and b was equal to the y-intercept when it was in this form. The average rate of change, we talked about this yesterday, looking at the average rate of change between 2 points on some function. Basically, we were looking at the change in our y values over the change in our x values, which was similar to finding the slope between 2 points. So the average rate of change of a linear function we said it could be written that rate of change, or the change in y, was written as the triangle and then the y, and then a triangle over the triangle x, all over the change in x. So it's just a different notation. Couple of things to know is if m is greater than 0, if our function, our slope is a positive number, our slope is positive, it's increasing, the line is increasing. If our slope is less than 0, then the line decreases. And if it's equal to 0, it's a horizontal line. So that would be in the form of f of x equals some number. So maybe b. B equals a constant. Or y equals b. And then if m is undefined, then we have a vertical line. And this was in the form of x equals some number. So let's say A, where A is some constant. So really quick, if h of x is given to be negative 2/3 x plus 4, and we're asked to find the slope and the y-intercept, it's already in that form that we can tell what the slope and the y-intercept is. Slope is negative 2/3. The negative can be out front. And our y-intercept, well, that's when x is 0, our y value is 4. Use the slope and the y-intercept to graph. We already were doing this last week. So let's plot our y-intercept, which is at 4. Once we know a point on our graph and we graph it, we can use the slope to give us directions on how to get other points on the line. And so if I use this as negative 2/3, negative, so that's how much we're falling. We're going to go down 2, and then we're going to run over 3 is positive when I go down 2. If I go down another 2, I would run over 3. So I have an x-intercept there. If I used it as positive 2, then 3 would be negative. So if I went up 2, I'd have to go 3 and left. So we were able to graph it. So it wants to know, C, what is the average rate of change of the function. It doesn't matter where you choose 2 points on this line. Any 2 points that you choose, as long as they're not the same. Any 2 points that you choose on that line and you found the change of y over the change of x, you're going to get the same result when you simplify it down. And that's true for lines. And so our average rate of change is constant. It's always going to be the same average rate of change. And so our average rate of change is basically just our slope. So the average rate of change on a line. So yesterday we were finding average rate of change on 2 points of a function that was not necessarily a line, and we had to find those points and find the slope. Okay, so we got m then is negative 2/3. Determine if the function is increasing, decreasing, or constant is part D. So is h of x increasing, decreasing, or constant? Well, that has to do with the slope and what value our slope is. And m is equal to a negative 2/3. That's a negative number. That's less than 0. So it's decreasing. So you might be given some information and asked, does this information relate to a function that is linear or nonlinear? If it's linear, determine the slope. So we're given x and we're given y, which is what f of x is at the x value. So we have a point, or x is -2, y is -4. We have one at -1, 0, 0, 4, 1, 8, and 2, 12. So basically we have points that are on the line. We want to see, is this a constant rate of change? So let's see what's going on. Let's look at our x value and our y value from one point to the next. And so notice here from -2 to -1, basically we add 1, right? To change from -2 x value to a -1 x value. From -1 to 0, in order to get from -1 to 0, I'm adding 1. 0 to 1, again, I'm adding 1. So we're having the same rate of change for our x values. We need to make sure we have the same rate of change for our y value between each value. So from -4 to 0, you would be adding 4, right? 0 to 4, I would be adding 4. 4 to 8, I would be adding 4. 8 to 12, I'm also adding 4. So the change in y is over the change of x. So m. Our change in y each time was 4. All over our change in x each time was 1. And because they were the same rate, it's equal to 4. And it's linear. And it asked us if it was linear to find the average rate of change, which we did, or determine the slope, which we did, which was 4. What if it had been same directions, same x values, -2, -1, 0, 1, 2. Our y values, though, all of them are 8. Does this represent a linear function? So notice each increase, right? Yay, I can get in a chat, so maybe you guys are answering. I can see it. It's lost in the underneath. Okay, so I found the chat. It says no. Everybody agree with that? It's not a function, or not linear function, it's a function. So as long as the rate of change is equivalent, for each x and y value, we're good. And so notice that the rate of change between our x values is always 1. And our rate of change between our y values, well, from 8 to 8, we're not changing, right? That's 0. From 8 to 8, I'm not changing anything. Again, that's 0. 8 to 8, I'm not changing anything. And so rate of change for my y value, that was 0. All over the rate of change in my x value, that was always 1. So it's a linear function. If we graph that, you get a horizontal line. And our slope is 0. One more, same type. Same x values going from -2 to +2. So negative, and including the integers. So -2, -1, 0, 1, 2. This time our y values are 0, 1, 4, 9, and 16. So linear function. Change of x is good. Change of x is always 1. But let's look at the change of y. The change of y, right? From 0 to 1, we have 1. From 1 to 4, that's a jump of 3. From 4 to 9, that's a jump of 5. From 9 to 16, that's a jump of 7. They're not changing at the same rate. So we can say that it's not a function. Not a linear function. So a lot of these problems in this section are things that we've done in this class, and is review probably. It's just a little bit of a different notation. So for instance, if you were given f of x is defined to be the equation 3x plus 5, and g of x is defined to be the equation -2x plus 15. And you want to find when is, for part A, f of x equal to 0. Or it says solve f of x equals 0. Well, you should know that we're setting our equation f of x, which is 3x plus 5, equal to 0, and solving for x. We got a linear equation, so we isolate our term with x, get 5 to the other side, we get 3x equals -5. And divide both sides by 3, we get x is -5/3. And then it wants to know when is f of x less than 0? Well, if we had just solved for when it was equal to 0, as long as I didn't multiply or divide by a negative number when I was solving for x, it shouldn't have changed my result of my inequality. So I was looking at when is 3x plus 5 less than 0. Well, subtracting 5 doesn't change my inequality. Dividing by 3 doesn't change my inequality symbol. So x is less than negative 5/3. B, when is f of x greater than 0? I'm kind of doing different pieces, sorry. Let's not do that, we already did that. How about when is f of x less than or equal to g of x? So f of x is our equation 3x plus 5. Our lights are like totally flickering. Is less than or equal to g of x, which is negative 2x plus 15. Okay, so we want to get x's to one side, constants on the other side. So let's add 2x to both sides and let's subtract 5 on both sides. So we get 5x is less than or equal to 10. So this would occur when x is less than or equal to 2. Okay, so let's kind of look at the graph of both of those. Let's graph f of x first. Well, it's already in linear form. That was, remember, 3x plus 5. So we have a point at 0, 5, and our slope is 3. I can write that as 3 over 1. So down 3 over 1 to the right. Down 3 over 1 to the right. When it asked us, what value of x is f of x less than 0? So another way to think about this, if we're looking at the graph, this is saying basically when is our graph falling below the y-axis? This is saying when is y less than 0? So the graph is below
Yes, sir.
the y-axis, yes.
Isn't the graph supposed to be the other way because the slope's positive?
You're right. Why was I going? You're right. Thank you.
No problem.
Let's try that again. I don't know if you guys can see that. Now that I said it, it just stopped. But my lights are totally flickering. It's like bizarre. Anyways, so again, 5, 1, 2, 3, 4, 5. Starting again. Rise 3. And we're going to go over 1 to the right. if I had fallen 3, 1, 2, 3, I would have gone over 1 to the left. When I went to go explain this next part, I would have noticed that something was wrong. So let me go down another 3 and over 1 again. So I'm looking at when is y below the y, when is y less than 0? So when is that below? And it should say the x-axis. Right? Your y values are negative when it's below here. So the y values are negative. And we found that to be when x was smaller than negative 5/3. So that's negative 1 2/3, which is right here. So now any x value you chose that's smaller than this, that's going to give you an y value that is negative. If you chose an x value to the right of negative 5/3, notice that your y value you're hitting is above the x-axis and positive. So let's look at that other piece where it says, let's graph now both of f of x and g of x together and kind of relate what it's saying with f of x is less than or equal to g of x. Okay, so if we graph f of x again, we have a y-intercept at 5. If we rise 3, we run 1 to the right. If we fell 3, 1 to the left. And this was our f of x. G of x, though, that was the equation. What was it? Negative 2x plus 15. Oh, well, that's not great. Because I'm a little worried because that negative or 15 is way up there, but that's okay. Okay, so it was 15. No, it wasn't. Negative 2x plus 15. Negative 2x plus 15. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my slope is negative 2. So if I go down 2, I would run over 1. Down 2 over 1. Down 2 over 1. Makes more sense this extends. Sorry that I'm going through my writing. Okay, so we're trying to find out when is f of x smaller than g of x. So we're looking at what x values give us a smaller y value for f of x than the y values for g of x. So basically we're trying to figure out when is this pink piece or purple, whatever color you want to call that, above the graph of the other one. So notice that's, we're going to find where they intersect. And this pink piece is above the black piece, meaning the y values are bigger than this over here when x is this direction. So we saw that was when x was less than or equal to 2. Okay. Does that make sense? So maybe you've solved them before, but and not really looked at the graph of what's going on if you had graphed both of those linear equations. Look at a couple of applications. So the cost in dollars to tow a car is modeled by the function c of x. Okay, so we're given what the equation is. C of x is equal to 2.5x plus 85. This is the cost to tow a car, where x is the number of miles towed. Okay, so part A, you should be able to answer questions about it. So what is the cost of a car, towing a car 40 miles? Well, they basically gave us what x is, right? And so we can figure out what y is, knowing what x is. So we're given x is 40. So wherever we see an x in our equation, we're going to replace it with 40. So c of 40, this is equal to 2.5 all times 40 plus 85. Should be 100. Right? So we get 100 plus 85. So 185. And we're talking about dollars. So $185 to get towed for 40 miles. If the cost of towing a car is $245, how many miles was towed? So the cost was, what did I just say, $245? How many miles were towed? Okay, so we know the cost, but we don't know the miles. And so we're setting our equation, the cost, which is 245, equal to 2.5x plus 85. So we want to get x by itself. We would subtract 85 on both sides. So 245 minus 85 gives us 160 is equal to 2.5x. divide both sides by 2.5. You get 64. So that was representing the number of miles towed. If you only have $150, what is the maximum? Number of miles you can be towed. So we know, or we should know that we want 2.5, the cost of the towing, X plus 85. We know that cost, C of X, has to be less than or equal to 150. So if we subtract 85 from 150, we get 65. So we have 2.5x is less than or equal to 65. Divide both sides by 2.5. Sorry, that was 65. Divided by 2.5, we get 26. So they can go 26 miles is a maximum number they can be towed. What is the domain of C? Okay, but I got to be careful because this is looking at an application problem. If I was just looking at that equation and I was noticing the domain, that would be any real number. I don't have any trouble spots there. But we're talking about application where C of X is cost. So it doesn't make sense to have, well, C of X is also my range. Doesn't make sense to have a negative cost, but it also doesn't make sense to have X. X is the number of miles being towed. So it doesn't make sense to have any distance towed being negative. So we know a domain is representing our input, which is X in this case. And so I know I can't have it less than 0. I guess it's possible the tow truck came out and didn't actually tow it. So X has to be greater than or equal to 0. What does the slope represent? In this problem? So a lot of times rewriting it as a fraction is helpful. Oh, shoot. What's happening in your class? Hopefully you can still hear me. My computer's turned off again. Come on. Okay, I didn't touch anything and it turned off on me, sorry. So we're representing the slope, and I was saying it's best if you rewrite this as a fraction. So 2.5 over 1. This is the change in our cost, C of x, over the change in x, which is miles. So you can think of this as cost per mile. So it's going to cost $2.50 per mile towed. Okay, so that is, let me do one more, a supply and a demand problem. And then we'll see about break or going on to the next section. Okay, so suppose that the quantity supplied, S, and the quantity demanded, D, of hot dogs at a baseball game are given for the as the following functions. So the supply, S of P, is equal to negative 2,000 plus 3,000 P. And the demand, D of P, this is equal to 10,000 minus 1,000 P. Where P is the price of hot dogs. So A, find the equilibrium price for hot dogs at a baseball game. What is the equilibrium quantity? So find the equilibrium price of hot dogs. An equilibrium quantity. Okay, so equilibrium price. It's an equilibrium when the supply is equal to demand. So we're looking at when is S of P equal to D of P. So we're looking at when is our equation for our supply, negative 2,000 plus 3,000 P equal to 10,000 minus 1,000 P. So we're trying to solve for price here. And so we want to get all the terms with P to one side, all the terms without P to one side. So if I added 1,000 P to both sides, 3,000 P plus 1,000 P, that's 4,000 P. And if I added 2,000 to both sides, 2,000 plus 10,000 is 12,000. Divide both sides by 4,000, I get P, well, 12,000 divided by 4,000, I get 12 divided by 4 as it reduces, which is 3. So the price would be $3. Okay, so if you sold your hot dogs at the baseball game for $3, the supply, how many hot dogs you have, would equal the number of hot dogs that were demanded and sold. And now we want to figure out what that quantity is. So finding out the quantity, it doesn't matter which equation you use, because that price, $3, is the same for S of P or D of P. So we can look at S of 3, or you can look at D of 3. So S of 3, that would be negative 2,000 plus 3,000 times P, which is 3. So we have S of 3 is equal to negative 2,000 plus 9,000, which is 7,000 hot dogs. So next part of that question says, determine the prices for which the quantity demanded is less than the quantity supplied. Oops. So determine when the quantity demanded, that was D of P, is less than the quantity supplied. So less than S of P. We pretty much did this information, except that it wasn't with an inequality sign. And our equations were on other sides. So if I had rewritten this, it's basically 10,000 minus 1,000 P has to be less than negative 2,000 plus 3,000 P. We had moved things so that our P was on this side. And we had gotten 3. So determine the price for which the quantity demanded is less than what is supplied. So this is when the price is above $3. So what do you think eventually happens to the hot dogs if the quantity demanded is less than the quantity supplied? So if you were selling hot dogs and you had people were buying less hot dogs than what you had to supply them, what would you do to your price? Would you keep it $3? Would you raise it $3? Would you mark it below $3? So people don't want your hot dogs. How are you going to get them to now want to buy your hot dogs? Right, so we're going to want to drop our price because we don't want extra hot dogs. They're going to just go bad. So we want to sell all of our product if possible. So let's drop our price. But we don't also want to drop our price where it's too low that we're not making money, we're actually losing money. So you got to be careful that we would drop price. Okay, so that was 4.1. .3, we are skipping 4.2. It talks about quadratic functions and their properties. Okay, so recall quadratic equations were written in the form of ax squared plus bx plus c. We had to put that little stipulation on there that a couldn't be 0, because if it was 0, then it's no longer quadratic, it would be linear. We saw with transformations of graphs that we had y equals x squared. That number, if we had y equals ax squared. If a is bigger than 0, this does not do any reflection on our graph. Our parabola is going to face upwards. We saw, though, if we multiply by a negative number in front, that was a reflection across the x-axis. So really the value of the number in front of our x squared can help us notify which direction the parabola faces. And depending on what way the parabola faces depends on if you're going to have a maximum or a minimum point. And these would actually be absolute max or absolute min, depending on which way it faced. This point here, these are our vertex, and this would be a absolute min. So if a is less than 0, parabola faces down, we have an absolute max. Quadratic equations can also be written in the form of f of x equals a times the quantity x minus h quantity squared plus k. This is actually called the vertex form. In a quadratic. So if we think of this with transformations, this h value, x minus h, that is taking our parabola, and the minus h is shifting it to the right h units. And so that point, our vertex that was at 0, 0, if I shift that to the right h units, 0 plus h is h. And then this plus k outside shifted my parabola upwards. And so if I shift my parabola up k units, then my vertex that was at 0, 0 is now at hk. So this is our vertex. Again, if a is less than 0, it faces down. If a is greater than 0, it faces up. They don't really talk too much about it, but they say that if it faces down, and you'll learn more about this in calculus, this is called concave down. If your parabola is facing up like this is called concave up. Couple other things that you should be aware of. So let's say, and it doesn't matter where our parabola is, I'm just going to put it in the first quadrant, but it really doesn't matter. And it doesn't matter which way it faces. Just happen to put it up. Again, HK here. That's H is the X value of my vertex. K is my Y value of my vertex. Notice that if we folded our paper along this vertical line through X equals H, remember vertical lines are in the form of X equals a number. X equals H is called our axis of symmetry. So basically I could fold my paper along that line and it would be a mirror image across. Notice depending on which direction your parabola faces, depends on what your domain's your range is going to be. Domain is all real numbers, but if our parabola faces upward, notice that the Y values that we're going to get are going to be equal to or greater than the vertex, the Y value of the vertex. So we can determine the range depending on which direction. So range, if A is less than 0, we know our parabola faces downwards. This is at point HK. So for our range, Y has to be less than or equal to. Okay. If A is bigger than 0, we know our parabola faces upwards. Again, this is at HK. So our range is all of our Y values which are bigger than or equal to K, and hit all those Y values above. So sometimes locating where the vertex is really helpful when you're going to graph this. The reason is because graphing, a lot of times we want to find the intercepts, but sometimes your parabola doesn't cross the x-axis, or later on we'll see when they're sideways, sometimes they don't cross the y-axis. But basically, right, if I had a parabola that fell above the x-axis and it was facing upwards, notice there's no x-intercept. Or if I had a parabola below the y-axis and it faced down, again, there's no x-intercept. Or it could be over here, up, or down here. But any of these cases, it's never going to cross an x-axis. And so you could save a lot of work for trying to find that x-intercept. Algebraically, though, if you went through to find it, remember that's when y is equal to 0. You're looking at when is f of x equals 0. Well, what's going to happen is you're not going to get a real number as a solution. So there will be no real solutions when you solve. So again, being able to determine where your vertex is, what direction it's facing, you can save time possibly for going through the work to find the x-intercept. So for a test though, if you didn't do the algebra, you would just explain why. Okay, so let's look at an example. Let's say you had f of x is equal to x squared minus 2x minus 3. I haven't given you the formula other than the equation being in vertex form to be able to tell what the vertex is. And so if we want to find the vertex, so let's say part A was find the vertex. So that means that we want to put it in the form. So trying to manipulate this equation to look like some coefficient A all times x minus h quantity squared plus k. So notice that's a perfect square in there. And so we need to manipulate this f of x so that has a perfect square. Fortunately, that number in front of my x squared is 1. And so I can just use and do figure out what I need to add to make that a perfect square. So I have x squared minus 2x. I want to figure out what I need to add. So I'm going to put plus and a space here. But instead of adding this number to both sides of my equation, this I'm going to manipulate as if I subtract that number on this side. Well, technically I'm adding a fancy way of saying 0 if I add and subtract it. And then I have my plus my constant, and my constant in our case was minus 3. Okay, so that same number that adds to give us -2, when you multiplied it together, well, we half it, so that's -1. So -1 times -1 is +1. So to make this a perfect square, I need to add 1 to those x terms. And so really I want to add 0 here. So I'm going to write it as +1 minus 1. And so let's now rewrite those first 3 terms as the perfect square. And so we have f of x is equal to, well, x squared minus 2x plus 1 is the same as x minus 1 quantity squared. And then we have outside of that perfect square, -1 minus 3, which is -4. So it's in vertex form, which is helpful. You should be able to identify what the vertex is. Opposite sign, because you're going the opposite direction when it's inside, so it's +1. We're going to go down 4, so -4, 1 minus 4. Your A value is equal to 1 here. It's greater than 0, so I know my parabola is facing upwards. So let's just plot that real quick. We have 1, -4. Let's go over 1 to the right and down 4. And we know A is positive, so it's going upwards. And so we know that it must have an X-intercept. In this case, multiple 2 X-intercepts. So let's find the intercepts, if they exist. So X-intercept, this is where we let y equal 0 or f of x equal to 0. It does not matter. You can set this equation that we just got, the vertex form, equal to 0, or you could have set the equation we started with equal to 0 at that x squared minus 2x, what was it, minus 3? So either way, if I had it in vertex form, I would use my square root method. I would add 4, take the square root of both sides, and then add 1. If it was in this form, I notice it actually factors really fast. And so I might go and factor instead. So -3 and +1 multiplies to -3 and adds to -2. So this can be factored as x minus 3, x plus 1. So my x-intercepts are occurring at +3 and -1. it is always easiest to find the y-intercept plugging it back into the original. Because if we plugged in 0 wherever we see an x, it's just going to give us back whatever our constant was. So that's going to be at -3. So y-intercept, we're going to let x equals 0 and f of 0 equals -3. So let's plot a point at 0, -3. So you should also be able to answer questions like, what is the axis of symmetry? So that is always a vertical line. Our parabolas face up or down. Through the vertex. And so the x value of that vertex was at 1. And so it's going to be the equation of the line x equals 1. And the domain, the range, domain's easy. Range, all the y values that we're hitting, we're hitting all the y values at the y value of our vertex, which is -4, and everything above. So our range is y is greater than or equal to -4. Or if they asked it in interval notation, bracket -4 to infinity. You should be able to locate where it's increasing and decreasing, and it's changing directions when at the vertex. So notice on ours, when it's going parabola facing up, it's decreasing till we hit the vertex. So it's decreasing from -infinity to the x value of our vertex, which is -1. And then it starts increasing when x is -1, going to infinity. What if it said, when is f of x less than 0? Look at the graph. We actually already did a lot of the work. We don't have to go through and use an inequality to solve this. We already graphed it. So we're looking at when is y, when is our graph falling below the x-axis? So what value of x is the graph falling below the x-axis? That's where our y values are negative. So I notice it's here, right? These are when my y values are below the x-axis. And so we can tell what x values, it's starting at the x value of -1. And it was strictly less than, so I'm not going to include the -1. And it's stopping at the x value of, we found that x-intercept to be 3. Or another way to write that is -1 is less than x is less than 3. So if it wanted to know when it is above the x-axis, or when is f of x greater than 0, you're going to actually have two pieces. You have this piece of x's when it's less than -1. So that would be -infinity to -1 union but it's also occurring, our y values are above the x-axis for x values which are bigger than 3. So 3 to infinity. I meant to put that greater than, not less than. Okay, so I think that's probably a good spot to stop for a break. So we're looking at graphs of quadratics, and we looked at one way of finding the vertex of a quadratic was putting the equation in vertex form. Another way to find the vertex, there's actually a formula, and we could derive it by completing the square, but I'm not going to do that. But basically what this says is, if f of x is equal to ax squared plus bx plus c, then the vertex is at the point negative b over 2a. And then once you find that x value, if you plug that back in wherever you see an x and f of x, that's going to give you the y value of your point. So f of negative b over 2a. So I'm just going to get a new page. Okay, so looking at an example, let's say we have f of x is equal to 3x squared minus 8x plus 2. And so we want to find the vertex. And we know one way to do it is our h value is going to be whatever negative b over 2a is. So our b value is negative 8, so negative of negative 8, all over 2 times a, which is 3. So this is positive 8 over 6, which reduces to 4/3. Okay, so I know the x value of my vertex is 4/3, and I want to figure out what the y value of my vertex is, which is k. So k is equal to f of 4/3. So we're going to go in, and wherever we see an x, let's just go replace it with a parentheses. And then we're going to go and put in 4/3 in that parentheses. So order of operations, I have to square that 4/3 first before I can multiply by that 3 out front. So 4/3 times 4/3 is 16/9 minus, so 8 times 4 is 32/3 plus 2. So I notice that my first term, the 3, simplifies with a 9 in my denominator, giving me 16/3 left. So I notice when I go back to combine these, I need a common denominator. So let's multiply 2 by 3 over 3 to get that common denominator, and then go through and add them. So we have 16/3 minus 32/3 plus 2 times 3, 6/3. Well, 16 minus 32 is negative 16. Negative 16 plus 6 is negative 10, all over 3. So this is the k value of our vertex. So our vertex is at h, which is 4/3, k, which is negative 10/3. Is the vertex a maximum or a minimum point? How do you know? So looking at this, if we graph this, would the probability be facing upwards or downwards? And so again, that has to do with our value of A. Our coefficient A is 3. This is positive. That tells me my parabola faces upwards. So that means my vertex is going to be a minimum. What if it asked you to put the equation in vertex form? So we pretty much did a lot of the work already. We could go back and we could complete the square. The thing is that we would have to pull a 3 out of our x terms. And I noticed the negative 8 isn't a factor of 3. I mean, I could do it. And that would just be a lot more work. Since we already did the work and we know what our vertex is, 4/3 and negative 10/3, we actually know what h is. The h value is 4/3, and our k value was negative 10/3. We actually know what a is, the coefficient in front of that quantity squared, which was 3. So if we go back in and we rewrite this and put in our pieces, vertex form is a times the quantity x minus h quantity squared plus k. So f of x would equal, well, a is 3, all times x minus h is 4/3, quantity squared plus k, and k was minus or negative, so I'm just going to change that plus to a minus 10/3. So if it asked you to put it in vertex form, you could complete the square, or you could actually go through the process where you use a vertex formula to find the vertex and then put in your pieces where h, k is and what a is. So let's say you were given a graph. So given the graph, find the equation. So let's say you're given that you have a vertex down here at 1, 3. Sorry, 1, negative 3. And it also has a point at 3, 5. So we really don't know. It doesn't tell us where it's crossing the axes. It just gives us those 2 points on the graph. 1, negative 3, which you can tell is the vertex, and the 0.35. So a couple things we know. Vertex form. And we know what the vertex is. So we know that our H value is 1, and our K value is -3. So far, just with those two things, we have f of x is equal to a all times x minus 1 quantity squared minus 3. But we also have another piece of information. We know that this is a point on the graph. So we know that this has to be a true statement when x is 3, y is 5. Another way to write y is f of x. So if we rewrite this and plug in our x and our y value, we'll have an equation with just a in it, and we can figure out what a is. So f of x was 5 is equal to a times x, but x is 3, minus 1, quantity squared minus 3. So simplify. Work inside the parentheses first. So we have 5 is equal to a times, well, 3 minus 1 is 2. 2 squared is 4. So a times 4 minus 3. So linear equation, get a by itself. Let's add 3 to both sides. We get 8 equals 4a. Divide by 4, we get 8 times a is equal to 2. So we have our equation. Now we just have to go back in here and plug into 2 and for a. So our equation of that graph is f of x is equal to a, which is 2, all times x minus h, so x minus 1, quantity squared, plus k minus 3. Okay, so let's look at a couple of applications. So the monthly revenue are achieved by selling X wristwatch is R of X is equal to 75X minus 0.2X squared. The monthly cost C of selling wristwatch is C of X equals 32X plus 1,750. Okay, so we got revenue, R of X, and it's given to us as 75X plus 0.2X squared. And it's giving us the cost of the wristwatch is 32X minus, not minus, plus 1,725. Oops, and I'm wrong. 1,750. So revenue, how many wristwatches must the firm sell to maximize the revenue? What is the maximum revenue? So how many need to be sold the revenue? And what is the maximum revenue? Okay, so I noticed I did write that first equation down wrong. That first equation should have been R of X equals 75X minus 0.2X squared. So it's wanting us to maximize that revenue. So on these problems, it's either going to ask you to maximize or minimize. We're dealing with quadratics. Quadratics are either going to be maximized or minimized depending on which way it's facing. I knew something was wrong because I knew my coefficient in front of A needed to be negative for it to be facing down. So that's why I went back and looked at my problem. R of X is our revenue and we want to maximize this. And so let's rewrite it a little bit. This is the same thing as saying negative 0.2x squared plus 75x. Our A value is less than 0. Our coefficient in front of x squared is less than 0. Our parabola faces downwards. So we want to find the vertex. So h is negative b over 2a. So that's the x value that is going to maximize that. So if we look at our b value is 75. So we have negative of 75 all over 2 times a. So 2 times negative 0.2. So negative 75 all divided by negative 0.4. And that would give us h is equal to 187.5. Sorry. I'm trying to figure out now which problem I'm on. Okay. So how many wristwatch? I was looking over here because I noticed that my answer was not a whole number and I was trying to figure out how they wanted us to express this. Because how many wristwatch is going to maximize the revenue? It's not going to be, we're not going to sell a half a watch. So I'm not sure if that's how they wanted us to express that or if we wanted to look at rounding this up or rounding this down. I know this is symmetrical. And so I know if I round it down to 187 watches, that's going to give me the same value back as if I had round up to 188. And so let me just pause for a sec and see how the book expresses this. Okay, so they do not look at it as being a half a watch. And so they either round up or round down because it's symmetrical. This is 0.5. So basically if I round it up, it's the same amount of distance as if I rounded down. And so it's going to be either 187 or 188 watches. Will maximize the revenue. And so we need to either plug in, and you should get the same number as if you plugged in 187, should equal the same thing as R of 188. And so if I go back in there and I plug in, so I have negative 0.2 times x, I'm just going to do 187, quantity squared plus 75 all times 187. So doing that, we get $7,031.20. So this is our max revenue. That was just part A. Part B, profit is given to be the function P of X, and this is equal to your revenue, how much you make, minus the cost. So what is the profit function? Well, we have our revenue, which we're given to be negative 0.2x squared plus 75x minus, be careful, you need parentheses around the whole cost function because we're going to have to distribute that negative. And that cost function was 32x plus 1,750. So if we distribute our negative and then combine like terms. So we have negative 0.2x squared plus 75x minus 32x minus 1,750. So negative 0.2x squared, got 75x minus 32x. So that's going to give us a 43x positive, so plus 43x minus 1,750. And last question, C, how many wristwatches should be sold to maximize profit? And what is the maximum profit? So same sort of idea as the other one. Looking at this equation for my profit function, I see it's quadratic. I see that the coefficient in front of the x squared is negative, so I know it's a parabola facing downwards. So I know that the max is going to occur at the vertex. I need to figure out what the x value of that vertex is. So negative b over 2a, so negative 43 all over 2 times a. A is negative 0.2. So negative 43 divided by negative 0.4. So this is equal to 107.5. So to maximize profit, again, same idea, I can either round down or round up. So to maximize profit, they need to sell either 107 or 108 watches. And and we can figure out what that maximum profit is by plugging either 107 or 108 into X. So negative 0.2 times 107 quantity squared plus 43 times 107 minus 1,750. So we get back $561.20. The last thing in this section, I'm surprised actually is here, has to do with what is called the discriminant. The discriminant, if you're looking at a quadratic equation, is b squared minus 4ac. If you look, and the discriminant tells you how many solutions and what type. So the discriminant is b squared minus 4ac. This tells us the number of solutions and what type. Recall, if you looked at the quadratic formula, this was negative b plus or minus the square root of b squared minus 4ac all over 2a. And so notice that that discriminant, b squared minus 4ac, is the radicand. It's what's underneath the radical. And depending on, is that number positive, is it a negative number, or is it 0? Depends on how many solutions we have back. If b squared minus 4ac is bigger than 0, you got a positive number underneath the radical, and that's a real number. And so when you take negative b and plus that real number, it's going to be different than when you take negative b minus that real number. So if you have a positive number underneath the radical, you have 2 real solutions. Well, a solution is the same thing as when we were looking at when this was equal to 0. When we're looking at when that is equal to 0, these are also talking about, or when y is 0, this is our X-Intercepts. And so if I get 2 real numbers back, I know graphically we're going to cross the x-axis twice. If b squared minus 4ac is equal to 0, well, square root of 0 is 0. So when I take the numerator, negative b plus 0, it's the same number as negative b minus 0. And so I have only one real solution. And so I know, well, basically, if it's a parabola and there's only one solution or one place that's crossing the x-axis, it's actually not crossing. This is actually touching the x-axis there, and the vertex is going to be on the x-axis. So vertex is on the x-axis. And last but not least, if the number underneath that radical b squared minus 4ac is less than 0, you have a negative number. Well, square root of a negative number is imaginary. And so negative b plus an imaginary number, negative b minus an imaginary number in the numerator is still imaginary. And so they have two complex number solutions. And this would tell us that it does not, the graph does not cross the x-axis. So I think they were showing this because they were using this to determine, do I have to figure out what the x-intercepts are? Is it going to cross or not? I prefer figuring out where that vertex is, what direction, and then I could tell real quick if it's going to cross or not, and then do I need to solve for it. But either way, they would tell you, is that graph going to cross the x-axis, touch it, or not touch, cross it. So that is graphing quadratic equations. And the last section in chapter 4 that we're doing is 4.5. And I was surprised on how they showed this, but this is quadratic inequalities. So normally I show this by doing it algebraically and not graphically, but your book shows it graphically, and I think later on in the book it shows it more algebraically. Quadratic inequalities are different when you're solving versus linear inequality. Let me see. Your book, though, basically there's two different methods that you can look at. So when you're solving a quadratic inequality, one method, so maybe just called method A, doesn't matter what method, it's just a method. Get everything to one side of your inequality. So once you get everything to one side of the inequality, you're going to have a quadratic equation is either less than, or equal to, greater than, or equal to 0. You're going to graph the one side. You're going to find your x-intercepts. And then you're going to locate where f of x is above the x-axis. If it was f of x was greater than 0, once you had moved everything to one side of the equation. Or you're going to locate where f of x is below the x-axis, if it's less than 0. So kind of looked at the graphs before, and then you use the x values. Where this occurs. Okay, so let's say it was 2x squared is less than 5x plus 3. So this method says get everything to one side of the inequality. So let's subtract 5x and let's subtract 3. So if we do that, we have 2x squared minus 5x minus 3 is less than 0. So once we got everything to one side of the inequality, we want to graph the one side. We want to graph this equation 2x squared minus 5x minus 3. So we just found tools in order to do that. And so let's find the vertex. Well, h is negative b over 2a. I don't know if you want to do it that way. So negative of negative 5 is positive 5. All over 2 times a is 2. This is 5/4. My k value is f of 5/4. So let's go in and plug in or put in parentheses wherever we see an x in our equation. So 2 parentheses, that squared minus 5, parentheses minus 3. Using order of operations, we got to square the 5/4 first. So we have, this is equal to 2 times 5/4 times 5/4 is 25/16 minus 5 times 5, 25/4 minus 3. I'm going to leave a little room there because I'm going to need a common denominator. So let's simplify this a little bit. This 2 times 25/16, that 2 simplifies with a 16 down in the denominator and makes it an 8. So I'm noticing that my LCD of 25/8, 25/4, and negative 3 is 8. So let's go in and get a common denominator of 8. So I need to multiply 25/4 by 2 over 2, and I need to multiply negative 3 by 8 over 8. So we have 25 minus 50 minus 24 all over 8. 25 minus 50 is negative 25. Negative 25 minus 24 is negative 49 all over 8. Okay, so we found our vertex 5/4 and negative 49/8. Plotting wise, it makes more sense to me to have it as a decimal or a mixed number. 5/4 is 1 1/4. Negative 49/8, what is that, 6? So that's negative 6 1/8. Okay, so let's see if it even falls where it falls. So the vertex is 1 1/4 and negative 6 1/8. Just estimate it. And we know our parabola, because our a value is positive, is facing upwards. And so we know it's going to be crossing the x-axis there. So we need to find our x-intercepts. Okay. So we're looking at when is 2x squared minus 5x minus 3 equal to 0? So when is 2x squared minus 5x minus 3 equal to 0? I notice I can use my AC method, or I can use my quadratic formula. AC, A is 2, C is -3. Multiplying that together, I get -6. I'm looking for two numbers that multiply to -6 and add to -5. That would be -6 and +1. I can rewrite my middle term using that. So 2x squared minus 6x plus x minus 3 equals 0. Factor by grouping, I can pull out a 2x, which gives me x minus 3. Think of it as factoring out a 1 if you want. X minus 3 is the same thing as I have over here. I can pull it out. So it factors as x minus 3 times the quantity 2x plus 1. So x minus 3 is 0 and x is 3. And 2x plus 1 is 0. If I subtract 1 divided by 2, it's when x is -1/2. Last but not least, it's saying when is that equation less than 0, right? So we're looking at what are the y values where this is less than 0. Well, the y values where it's less than 0 is that piece that's falling below the x-axis, and the x values that give us that, it's everything in between this -1/2 and this +3. Another way to write it is -1/2 has to be less than x, which has to be less than 3. So there's our solution. The other method is basically graphing both sides of your equal sign and then finding out where they're intersecting each other. So basically you're setting them equal to each other. You're gonna have to get everything to one side. You're gonna find that they're equal to each other at these x-intercepts. And then look at it. Maybe let's do a different one using the other method. This one would be nice. So if we had x squared plus 7x is less than -12. So the other method graph both sides of the inequality. So in our case, we want to look at two separate graphs, but on the same axis. We want to look at when is f of x equal to x squared plus 7x. And let's graph when the other side, g of x, let's call it g of x, equals -12. Okay, so graphing f of x, I can tell what the x-intercepts are really quickly by setting f of x equal to 0. 0 is equal to x squared plus 7x. I can factor out an x. So I notice that this is going to cross the x-axis when x is 0 and when x is -7. I should have, because y is -1, I should have moved this up. I'm sorry, -12. We can find out what our vertex is by looking at -b over 2a. So our b value is 7, so -7 all over 2 times 1. So -7/2, which is -3.5. And I need to find my k value, so I need to plug that in for f of x. So f of, I'm going to do the fraction, -7/2 is -7/2 quantity squared plus 7 times -7/2. So this is 49/4 minus 49/2. Common denominator, so -98 minus, -98 plus 49, that's going to give me -49/4. So it's -1.225. So that's -12.25. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we graphed our f of x. Yeah. And it wants us now to graph our g of x. Well, g of x is equal to -12. Y is equal to -12. That's just a horizontal line through -12. So we're trying to find out when is g of x bigger than our f of x. Well, that's everything that this blue line, when that blue line is falling above the green graph. So that's going to be everything right in here. So whatever these values are. So then you have to solve. So to find these values of intersection, so find where the graph or graphs intersect one another. So that's basically saying when is f of x equal to g of x? Or when is x squared plus 7x equal to -12? So quadratic equation, get everything to one side. This one factors. So add 12 to both sides. We got x squared plus 7x plus 12 equals 0. Two numbers that multiply to +12 add to 7 are 3 and 4. So x plus 3, that quantity times x plus 4 equals 0. So x is -3 and x is -4. Always going from smallest to largest. So g of x is bigger than f of x, or -4 is less than x is less than -3. Or another way to say this is -4 with parentheses on that, comma -3 parentheses. Personally, I think getting it all to one side first and finding the x-intercepts is easiest. Than graphing each separate equation. This one was a little easier because that one side was just equal to a horizontal line. But you're pretty much doing the exact thing anyways, because when you solve the equation, one equation equal to the other, you have to get everything to one side, which is what you are doing for the first method, getting everything to one side of the inequality. So we just finished 4.5. Yeah. So we just finished chapter 4.